In Boyle's law, the pressure and volume of a gas are inversely related at a constant mass and constant temperature. If pressure is increasing, then that means that the volume is decreasing. And if pressure is decreasing, then the volume is increasing. The equation for this is the initial pressure times the initial volume is equal to the final pressure and times the final volume. For example,
a gas occupies 100 milliliters at 500 kPa. Find its volume at 200 kPa. To do this, we must first identify the variables. The initial variables are pressure 1, which is 150 kPa, and volume 1, which is 100 milliliters. And the final variables are pressure 2, which is 200 kPa, and volume 2, which is the missing variable right now. So for now, we will call it x milliliters. To solve for x, or to find the volume at 200 kPa, we must multiply and divide away all our variables until we reach 75 milliliters, which equals to x. So the volume of the gas at 200 kPa is 75 milliliters. The work is as shown.
To demonstrate Boyle's law and make it visible, we have a 2-liter bottle which has been filled with water, a medicine dropper in which we placed food coloring or vegetable dye. We're going to drop it into the bottle. We notice that the air in the dropper causes the dropper to float. We put on the cap, tightly sealing it, and then we're going to squeeze the bottle and thus increase the pressure on the air inside the dropper. Releasing the pressure.
in Charles' law, the volume and temperature in kelvins of a gas are directly related. As volume is increasing, so is temperature, and as temperature is decreasing, so is volume. The equation for this is volume 1, which is the initial volume, over temperature 1, which is the initial temperature, is equal to volume 2, which is the final volume, over temperature 2, which is the final temperature. For example,
a gas occupies 473 centimeters cubed at 36 degrees Celsius. Find its volume at 94 degrees Celsius. First, we must identify the variables. The initial variables are volume 1, which is 473 centimeters cubed, temperature 1, which is 36 degrees Celsius, which is also 390 degrees Kelvin. Volume 2 is the unknown, and temperature 2 is 94 degrees Celsius, which is also 367 degrees Kelvin. Multiply and divide away until you find your missing variable x, which is 562 centimeters cubed at 94 degrees Celsius. As Christina stated before, as temperature increases, volume increases.
Calhouns' law states that pressure is directly related to temperature at a constant mass and a constant volume. If temperature is increasing, so is pressure. If pressure is increasing, so is temperature. The equation for this is P1, which is initial pressure, over T1, which is initial temperature, is equal to P2, which is final pressure, over T2, which is final temperature. For example,
at 300 Kelvin, the pressure of a gas in a steel container is 3 atmosphere pressure. If the temperature is increased to 450 Kelvin, what will be the gas pressure inside the container? First, we must identify the variables. The initial variables are pressure 1, which are 3 atmospheres, temperature 1, which is 300 Kelvin. The final variables are pressure 2, which is our unknown, and temperature 2, which is 450 kelvins. Multiply and divide away your variables until you reach 4.5 atmospheres is the pressure at a temperature of 450 kelvins.
That's flammable. Oh, you hear the carbonated water sizzling. Whoa. He ran too.
thank you guys for watching. We really hope you enjoyed it. And sorry if it was super boring, because I'm sure it was. And also, thank you, Mr. Calhouns, for a great semester and a great year.